Computer Science 150, operator overloading. So in our last session, we talked about friend functions, and these were a nice compromise between regular functions and member functions for a class. We invoked them like a non-member function for the non-member function. There was no calling object and no past object that we had to keep track of, but we still had access to the member variables, just like we did with a member function. That was for both objects. The declaration goes in the class definition, and the definition we still write at the bottom, but we don't have to do the scope resolution operator to get it in there to work. And what we can do now is we can actually overload some functions. And you may recall overloading functions from earlier in the course, or we've talked about overloaded constructors for classes. Just as a recall, the overloaded functions are multiple functions with the same name, but they have different signatures. So the signature constitutes the name of the function plus the parameter list and the types that are sent in the parameter list. We can actually do the same thing for operators. We can overload operators. So we can make a new version of the operator for plus that will work with classes, or minus that will work with classes, or compare for equality. And so if we can do this, this allows us to write more natural code. So if we had two patients or two students, we could say if patient 1 is equal patient 2, or if student 1 equal student 2 in our application code. And that's a more natural way to write that code versus what we've been doing with the regular functions, the member functions, and the friend functions. This looks more natural, and it's easier for someone who's using the application code to decipher precisely what's going on. So the way we can do this is we can overload our operators to work with the class. We do this, again, these are going to be friends, so they're going to have access to the private member variables. In the case of compare for equality, it will return a Boolean true false value. We use the keyword operator to signify it's an operator, and then give the name of the operator. In this case, it's equal or compare for equality, along with the parameters we need to consider, patient 1 and patient 2. So the definition, it doesn't use the word friend, but everything else goes down there for the top of the definition. And then we write the code. And it's going to look very similar to the friend function, except for the top part of it, the declaration, and the part that goes at the top of the definition. So some rules for this operator overloading: we can't create new symbols. So you can't, define, what does an ampersand mean, or, some other character on your keyboard that doesn't have a meaning semantically within C++. Can't change the number of arguments. So, equal, we can't have it, look at 3 different things at once. We also can't change the precedence. So we can't do things like make addition a higher order of precedence than multiplication. At least one parameter needs to be a class type, and we need to use it sensibly. Don't use plus to mean multiplication and equal to mean addition. With your class, if you were making a complex number class and you define plus to mean multiplication of 2 numbers that were complex numbers, that wouldn't make sense. Or equal to mean addition. It just makes a confusing code. Perhaps if you're doing something like entering into the International Obfuscated C programming contest, that might be an okay use for that. But in general, for 99.9% of things, try to use them where they make semantic sense. The assignment operator, that one gets a little bit tricky, so we're going to save it for 151. And for CS150 purposes, there's no need to overload this because we're not using dynamic memory. Because if we don't use dynamic memory, we can use the built-in assignment operator, and it's going to work exactly the way we want. Once we add in some complications like dynamic memory, then we need to overload the equality operator or the assignment operator. In addition to overloading operators such as plus, minus, multiply, assignment, it would also be nice to overload insertion and extraction operators. And so we can now do things like C out patient 1 or C in patient 2 and have those work the way that we would expect them to do that. So basically these two arrows are the insertion operator. These are going to insert things into the C out stream. And this is actually a binary operator between C out, which is the stream, and the value that we want to insert into the stream. In this case, number and the string that follows it. And we actually return C out as a result of this operation. So here's how we would do that in code if we had a class. So we would declare it as a friend function. So it has access to the individual member variables without going through the class interface. We're going to return a type of output stream. And notice that one's passed by reference. It's going to be an operator, and the operator are the two arrows pointing left that we use typically with cout. We pass it the output stream outs, and we pass it the individual class object that we want to output. The definition basically, instead of using cout, we would use outs because that's the name of the output stream that we passed. And then we would simply use that like we would any ordinary output statement. And at the end, we make sure that we return outs. And then we can just use that the same way that we output any ordinary type of variable. If we're just doing it to the standard output, cout patient 1. And voila, it works. We can also, we can also overload the extraction operator, which is the one that we use with CN. This one uses an input stream. It's an operator, and it's the two arrows pointing right. We pass it the input stream, and we pass it the object of the class that we're considering. And for the definition, we would basically do it just like we would with CN, except here the stream is known as ins, and we have to return ins because it's expecting a stream to be returned. And then we can use it just like we would CN for any ordinary variable. And that's it. We'll explore a little bit more of this when we get into the classroom session. Thanks so much for watching.